Vanakkam. So we will start today our lecture, continue from the yesterday class. So far what we try to do is actually we try to understand how the earthquakes are occurring. Okay, so how the olden days the earthquake was understood by the people, and then what are the hazard earthquake can cause. Okay, so what are the different type of natural hazards. Okay, so followed by how this natural hazard causes the disaster. Okay, so then among the earthquake, what are the different type of possible hazards are there. So then followed by how to measure the earthquake, how to classify the earthquake. Okay, so then the earthquake mechanism, how the earthquakes are occurring, so where it is occurring. Okay, so all those things we try to understand. So the fault mechanism and so many things. So followed by we also seen that so how to record the earthquake and instrumentation, how to quantify the earthquake, basically how to quantify the earthquake, that also we was actually started understanding that. So then how to interpret a recorded data using the wave propagation theory. Okay, so how to interpret a record, we in the perspective of the seismology as well as in the perspective of the engineering. So we have seen time domain parameter, frequency domain parameters, so how to interpret all those things we have seen, and we also seen that this interpreted data further used to derive a predictive models in the earthquake. As I told you that these predictive models are very important to estimate a earthquake hazard or predict earthquake hazard. So the whatever knowledge we gained so far, basically the understanding of the earthquake, so which is a seismology part, more or less it's predominantly what we covered was actually seismology part. So this understanding of the earthquake only will give you the proper way forward for predicting the earthquake hazard. So the next part is basically the application using the knowledge what you are gained, okay, in the way, engineering perspective. So before going to the application, as we have covered different variety of subject starting from the natural hazard to the earthquake parameter prediction and then predictive equations kind of things. So it may be necessary we should recap what happened in the so many classes with the highlights on the different part, so that it will be clear even if you are not something is clear on the earlier. So now this recapping, okay, so the revision of this part is will be useful, because as next level we are going to talk about the application, how this knowledge what you gained will be used for the application. So that is what we are going to talk about. So before going to the application part, okay, so we have to understand and recap the what we have done. So the next couple of hours I will be talking about the highlight of the each and every content what we discuss in the class, so that even the previous version video you are not able to watch or you didn't have time to skip or something was happened, this recap will help you to gather the very important aspect of the seismology part of this one. Okay, so the application before that. So we started basically try to understand the continent wise. Okay, so how the people are basically experienced a disaster on different continent. So that is what we started the initially. So we started discussing about the number of events the continent wise. So there are about 5 major continent, we can group them like Africa, America, Asia, Europe and Oceanic. So among that we have seen that the Asia is experiencing the very large amount of the disastrous event. So this disastrous event includes all the hazard, so including earthquake hazard. Okay, so it includes all the hazard including earthquake hazard. So we also seen that for this percentage of share, okay, so how many people will die, how the economical losses. So if you look at very carefully, so in Asia we found that around 68% of the people die due to this kind of natural disaster. Okay, so natural hazard, and when compared to any other continent. So we also highlighted that, so even though it is 70% of the people will die, the economical loss with respect to different continent, ours was almost equal to the European and America continent because of the cost of living difference. So these are all the way we try to understand how the disaster creates impact, like how many people will die, what is the economical loss we face during the earthquake. So our economical loss is not so much, but the human casualties are more in Asia, which may be because we have been highly densely located, so okay, densely populated. So that means many people live in the small area. Okay, so that is maybe the one of the reason. So this disaster so includes about 5 major category disaster, which is like biological, geophysical, climatological, hydrological and meteorological. So right now the hydrological and then the meteorological events are able to predict considerably. So the disaster or the mortality, so the number of people die due to these hazards are reduced considerably nowadays. So the biological things are still challenging, as you might have seen that. So we have been facing this COVID-19. Okay, so now which is one of the biological related hazard. Okay, so which is causes many people to die and lot of lockdown and economical issues, all those things basically biological hazard. So which somehow can be controlled or minimized. Okay, so some way of practice or doing some kind of traditional medicine or something like that. So the another hazard, okay, so the climatology, which is a drought and extreme temperature and wildfire. So this also we don't have much control, but generally these are all the problem in most of the cases, the forest regions, very hot regions kind of things. So the another hazard which is predominantly causing the lot of death and economical loss due to the infrastructural development problems. So those are all the geophysical hazard, basically the earthquake, volcanoes and dry mass movement. So where your construction quality or construction practice or the construction design is not capable of handling this kind of natural events, which will cause a death and as well as this one. So that is what we try to understand. So the geophysical hazard consists of 3 parts. So among that the earthquake is actually the more pronounced one among the all these 3. So we have been seen that how the percentage of the share disaster with respect to each subgroup and continent wise again. So this maps clearly shows the 5 major continent and also the each subgroup. You can see that the Asia, the number of event share on geophysical is are very high when compared to any other continent. So the other hazard basically the meteorological and then so are very high in American continent. So but it is slightly less in our place, but mostly these are all the hazard where you can predict. Okay, these are all the events where you could be able to predict using the state of art knowledge nowadays available. So these events, the failure or disaster or the whatever happens due to this kind of events other than geophysicals are able to control. Okay, so with the human knowledge and then the traditional practice. So this is actually the number of people die with respect to the each hazard type. You can see that even the 56% of the geophysical hazard is expected all over continent. In the Asia is 56% when compared to all over other continent. So but the number of people die due to this geophysical hazard actually 100 when you compare to any other continent. So that means if the 100 people die due to the geophysical hazard, that 100 happens in only in Asia. So but if other hazard, you can see that our percentage actually not very low, but relatively smaller, like when compared to geophysical hazard like 72, 62, so 86. So the understanding of geophysical hazard basically help, okay, to reduce the economic as well as the basically the so mortality rate or death rate in the Asian countries. Even the economic loss what we face also very high, particularly on geophysical hazard, but other hazard the economical loss is very low. You can see that the basically the hydrology and meteorological hazards are very high in the economical loss created by this hazard is very high in the America when compared to other continents. Okay. So that is the things we can get. So the overall the global wise, okay, so the occurrence of this hazard, natural hazard portions, so which we have seen that the Asia is always around 50-60% of the occurrence you can expect. So, the other continent also you can see their occurrence, for example, here you can see around, so 34, okay. So, the 50, I am only talking about the geophysical hazard, you can see here, okay. So, this is the percentage difference. So, basically these two the global portion occurrence of this, but because of occurrence of this, how risk we are. Okay, so how our future or our the number of death and economical loss for this kind of hazard. So, for the predicted for the future, you can see here. So, the level of exposure. Okay, so that means the level of exposure means, so how many events, how much you will expose. So, the red part goes a very high level of exposure. So, the Asia, US and then the, so the many part of the world that has, then the yellow portion. So, remaining the green and the blue. So, but because of this exposure, okay, how we going to affect or risking ourselves on. So, these things is the question, and the prediction model done by the scientists show that. So, even though the risk is very high at several developed countries, but the number of event expected on those countries are very high, but the risk due to that event is actually moderate to low. So, that is what you can see US. Okay, you can see, say the previous slide it was completely red. Okay, high level of exposure, okay, for the any kind of disaster, but it is a moderate to low level of risk. Okay, so exposure is very high, but the risk is moderate and low. But if you look at same with respect to Asia, you can see that the exposure also very high, and then the risk also very high. So, this has a several reason for that. So, one of them is improper knowledge, okay, improper preparedness, okay, so improper construction practice, so improper code of practice, okay, so highly dense the high density population. So, these are all the some of the issues which makes even a high level of exposure, high level of risk, where the western countries are developed countries. So, high level of exposure, but the moderate and low level of risk you can see here. So, the low and moderate level of risk. So, which clearly indicate that the disaster towards, particularly the disaster towards earthquake or any natural disaster. So, we need to upgrade ourselves to handle this properly. Okay. So, to handle this properly we need to upgrade. So, the one of the way to mitigate, okay, and the earthquake risk and preparedness, so to solution for all these things, okay. So, mitigate and reduce the risk is basically you have to go for the earthquake preparedness guideline. So, what we should do to those kind of things. So, we have discussed that we have to try to understand, okay, the perception of the origin of the earthquake and the propagation of the seismic wave. So, that is what. So, first we have to understand earthquake. If the earthquake comes, how the seismic waves travels. So, these two are the very major component, the first and priority component of the reducing and minimizing the risk. So, that is what we try to understand in our course as on now. Okay. So, then once you are done that, okay, so once you are able to predict, so the time domain parameters of frequency or predictive equation whatever. So, then you could able to have the expected seismic hazard at a particular location. So, then you have to understand the structural pattern what we built, house what we construct, how this kind of structure behave for this predicted hazard. So, the understanding of the behavior of all kind of structure under the seismic action which you understand here. Okay. So, first step one whatever. So, then once you know that these structures are sustained, these structures are not sustained, then you go for the rehabilitation and retrofitting of the existing structures. So, that is a very important steps to minimize, because as I told you that the earthquake never kill a people, only the structures which is built by the engineers or insufficient knowledge people will collapse, which causes lot of so mortality as well as the risk. So, the development of appropriate code of practice and giving the design values and guideline to construct a building, so will help to reduce this kind of hazard. So, the development of quality control to ensure to a correct application all legislation are the another important step to implement all those. So, if you follow these steps systematically, so you can mitigate and minimize the risk due to the earthquake or the death due to the earthquake or economic loss due to the earthquake. So, that is why the understanding of earthquake is very important. Okay. So, that is what we discussed in the first couple of hours. So, I have given a overall global picture what we have discussed, why it is important. So, even this information will be useful to handle your class. So, within the earthquake, okay, so once you identify earthquake as a better, so then we have to understand perception of the earthquake. So, the earthquake events occurs. So, earthquake is part of geophysical hazard, so which is a component of 5 major hazard in the world. So, in the earthquake can cause a different type of hazard. So, what are those hazards? So, that also we discussed. The earthquake can cause a direct ground shaking, okay. So, the ground displacement and flooding and landslide and liquefaction and fire and tsunami. So, these are all the different type of, okay. So, hazard one can expect from the earthquake, depends upon the site condition and infrastructure facilities and different things. So, all of them may not be possible at one place. Okay, so, but most of them possible at a few places. So, something like that we have to, these hazards will be very specific. So, we try to understand when these hazards are happen, what really happens in the from the past earthquake. So, we have been talking that the ground shaking hazard. So, the ground shaking hazard basically it is a direct shaking of earthquake, like vibration created by the earthquake. If the structure not able to handle that vibration, then it will collapse. So, those kind of failures are called as a ground shaking hazard. So, generally the structure which is not designed for a vibration, okay, only static they consider, they did not consider the dynamic, even they consider dynamic, but they consider a lower level. So, those kind of structures are may expect to fail this kind of ground shaking hazard. So, this is the typical example where you can see that a big disaster happened. So, during the Good Friday earthquake in 1964. Okay. So, this is the one of the classical example where the earthquake shaking caused. That means, the structure was stable, usable during the normal condition. When earthquake comes, these structures are failed, basically the structural components are failed. So, this kind of failure basically happens due to the failure of the structural component which is not capable of handling the load. Okay. Those kind of shaking effect is called as a direct ground shaking effect. Okay. So, this is the one of them. The second one is actually, so as I told you that when the seismic waves propagates from medium to medium, so from the seismic bedrock to engineering bedrock to the surface. So, because of the change in the medium material stiffness and thickness, so this undergoes a wave propagation, okay, wave modification. So, that causes a wave changes that we discussed as a amplification. That amplification produces a additional force to the structure that causes a collapse. So, here the structure may be considered, but because of the your amplification effect, so the what force you are consider is insufficient. Okay. So, that causes a amplification based hazard. So, basically, so this is the place where you can see the house you are constructed. So, this is actually the region, okay. So, where this is actually the bedrock. Okay. So, just I will give you the brief overview of the what is the amplification, why it occurs. Okay. So, this region basically filled with the soil. Okay. So, you have the soil here. So, when the earthquakes starts from here, so it radiates on different direction. Okay. So, it radiates on different direction. So, basically if you have the house here and then house here, so okay. So, depends upon the wave at this place and this place. So, depends upon the wave at this place and this place. So, basically you will get a different dynamic force or vibration level, which that is what we have seen in the wave propagation theory. So, particularly some of the structures which fails, this will be the direct ground shaking hazard. So, this is due to the amplification of the waves due to this portion, this power. This is basically amplification due to the soil medium. Sometimes the structural configuration itself not sufficiently designed to take a vibration. So, that causes a failure. So, that kind of failure we will call it as a basically amplification failure. So, that happens, for example, this is the typical bridge site. Okay. So, where the mass of the bridge, okay, generally the bridge you have the pier, then there is a foundation hidden below the ground, and the top of the bridge you will have the roadway, which is generally the wider in length. So, this dynamic force what it comes basically. So, as we have seen that when the medium is like that, so this dynamic force get vibration, this is keep shaking. So, if this shaking is not accounted the natural period of this system, and then this height, stiffness and height is not modeled properly or not understood how it behaved during this earthquake waves, this causes a imbalance between the head and foot. So, that create a collapse. That kind of collapse also we can say it as a due to the amplification waves due to the structural system. So, one is the amplification due to the soil system, which is called as a soil amplification. So, another is due to the structural system, the stiffness difference, mass difference in the structure will create a imbalance between the base and top. So, those who are I mean sitting in the seismically active area or people who are experienced earthquake. So, if you are living in the apartments which is relatively tall enough, so people living in the basement or the ground floor will experience less vibration than a people living in the 10th story or 12th story because of this mass imbalance and the shaking level created by the vibration or the amplification effect of the waves due to the structural system. That kind of things also call it as a amplification. This is the typical study which is caused due to such kind of amplification, the bridge got collapse. Okay. So, this is the typical study. So, then next is the ground displacement. So, the ground displacements, there is a permanent displacement, okay, caused in the ground due to the earthquake, which happens generally because as we know that the soil is actually assemblage of the particles. Okay. So, this particle size varies from micron, so 2 micron, 3 micron lowest size to the 50 mm, 100 mm, 200 mm to the largest size. It depends upon the geological formation and which area it is, all those things. So, when the particles, okay, the individual particles, cohesionless soil, where the particles you can see by the plain eye. Okay. So, that particle is we call it as a cohesionless soil. This soil does not have much attraction between the particle. So, those kind of places when the vibration comes, this vibration basically try to move the particle. The moving of particle basically result in the moving of the ground layers. You can see this is actually the ground layers movement. So, which causes basically the permanent ground displacement. This is the typical maybe the road where the movement is caused a crack and as well as the movement. Similarly, this is another embankments where you can see there is a huge amount of the failure due to the displacement of the soil. This kind of displacement is called as a ground displacement. This happens generally there is a soil which has a less attractive forces of the particle which basically moves during the wave propagation during the vibration created by the earthquake. So, that kind of hazard also is one of the major concern in the earthquake engineering. So, the another one is the landslide. So, this hazard generally occurs in the hilly region. So, where basically the landslide is expected due to the loose deposit of the hill formation. So, the shaking will basically brings down the whatever loose deposit happens. This bringing out the soil basically blocks the road and then the several death and lot of consequences in the hilly region, particularly the region like this Kashmir, okay, so the Sikkim, Tripura, all the hilly terrain wherever the hills are there. So, this is one of the concerns. So, the earthquake create a additional force in the slopes which is becoming unstable and collapses and causing lot of disturbance, and that disturbance basically landslide. So, even a small magnitude, okay, 5.5 or 6 moderate magnitude can cause 1500, 2500 landslides. So, this was some of the history where we can take it from the past earthquake. So, this will be the another major hazard due to the earthquake. So, we also try to understand a liquefaction. So, generally the liquefaction basically occurs in the cohesionless soil. As I has told you that when the earthquake comes, the cohesionless soils are having the free tendency to move. When it is saturated in this one, the effective stress reduces to 0. Okay, during vibration time, that instability and causes a ejection of that material out. So, this is actually surface features of the liquefaction. So, the understanding of liquefaction are very important, and this hazard also causes a lot of damages. So, this has been noticed in the about several olden earthquakes where it caused a lot of failure in the dams, houses and all. This is the typical cases where the liquefaction caused the dam embankment fail. Okay, earthen embankment to fail. This part you can see here. Okay, so the liquefaction occurred below. It not that always liquefaction expected to occur on the surface of the earth. It also can expected to occur on the below the earth surface and all those things. So, apart from these things, okay, these are all basically, so the earthquake and soil related thing. There are some hazard which is also related with the earthquake. So, one of them is the fire hazard. So, the fire hazard basically what happens. So, as in the urbanized way, people try to give the gas connection through a pipeline, okay, to the all the houses. This gas connection what it makes basically. So, this gas connection, these pipes are not designed for the vibration, to not able to handle the vibration during the earthquake. It breaks, that leakage of gases causes a fire, or leakage of electricity, short circuiting will cause us a fire. So, this was the many earthquakes fire was reported. This is the one of the classical example of the Loma Prieta earthquake. Okay, San Francisco earthquake, there are huge number of people died due to this fire, not because of the earthquake. That means the houses are intact, people are not died, but the fire created due to the leakage of the gas as well as the electrical short circuiting spread all over the city and many people died. So, the fire also one of the major hazard among the different hazard in the earthquake. Okay. So, then after the fire, so the another one is the tsunami. So, tsunami things are expected to occur only on the places where the city located to the coast. Okay. So, sea. So, the earthquake occurs below the sea or big water body. The fault is located. This fault causes a vertical displacement. Okay. That displacement basically lead to the enormous release of the energy to the water. That energy carried by the water when it reaches to the shore because of the less height. Okay. So, in order to compensate energy, the waves increases its height, wave amplitude or wave height, that wave hit here people who are near to the seashore or the big water bodies, that causes a lot of damage and people. This is the typical tsunami. Okay. So, 2004 tsunami. So, where people are running to escape from the tsunami, you can see how the wave height when compared to the normal sea level. Okay. So, this is a classical example. So, all this hazard, if you look at all this hazard, how it is occurred in the last 50 years. So, people scientists are done wonderful job by collecting all this earthquake and the number of people died and then try to compile and understand that. So, this is basically the disaster, okay, or deadly earthquake among the world from 1668 to 2008, which is roughly about a 40 years, okay, so period. You can see that, okay, these are all the earthquake, which is disaster means basically deadly earthquake means more than 10 people died due to this event. Then they tried to understand among the different earthquake hazard, which hazard causes a more damage, okay, more death toll. So, this is basically the share of each hazard, whatever we talk about the ground shaking, landslide, tsunami. Okay. So, the ground shaking includes amplification, ground motion, liquefaction, all of them clubbed together in the ground shaking, as all of them related to the ground soil. Okay. So, the landslide related to the hill, tsunami related to the sea. So, that is why these are clubbed. You can see that more than 75% of the hazard, okay, has been caused due to this ground shaking kind of, which may be direct wave or modified wave or wave causes liquefaction, or this kind of things are can be clubbed in that. You can see a 70% of the shaking basically. So, it is done on that. So, this is basically including the 2004 tsunami event. So, if you remove the 2004 tsunami event, which was a large number, okay, so you can see that close to 80% okay, of the hazard caused by the shaking. Okay, so the remaining major portion is the landslide, remaining is tsunami and missing. So, the including 2004, excluding the 2004. Okay. So, the ground shaking is the one of the major hazard which has to be considered in the design of building and then the settlement places where it has to be modeled properly. So, this is the non-shaking, like if you remove the ground shaking hazard and then whatever other hazard is there, if you club it, you can see that landslide, tsunami and is a very major component. Particularly landslides are the very huge, it is close to 70% when compared to any other art. So, here the 2004 tsunami is basically removed. Okay. So, the including 2004, if you see that the tsunami plays a major role, that the number of people died due to the non-shaking hazard, including Sumatra earthquake. Actually, the tsunami is a major component. Next is the landslide. So, these are all gives a idea, okay, how the natural hazard, the earthquake hazard and how it is important, how to mitigate. So, all those things we have discussed in the about more than maybe 2-3 classes in the last time, but I just summarized all of them here to give the glimpse and idea of the recapping the what we have done so far. So, with this we close this video. So, we will recap the next lectures in the coming classes. Thank you very much.